and welcome to Wildly Curious, where the questions are unhinged, the science is real, and honestly, we're just getting started. I'm Laura.
And I'm Katy. And...
Ever wonder why a bat might glow? Or how frogs made it to space long ago? Dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Wildly curious, where science gets strange and kinda hilarious. For nature's wonders to ancient funk, it's facts and fun rolled into one big chunk. Wildly curious, we're just wonderful. Come join the fuss.
All right, guys, so this is the fourth mini episode in season 13, where we're talking about niche scientists and just the bizarre things that they studied. So last week, Laura talked about
Fluid dynamics.
Yeah, urine and poop, and all the cool things that come from that, which is, again, the perfect segue into what I'm talking about. I'm going to be talking about scientists that are studying snail racing.
What? How does that have to do with urination and defecation?
Oh, wait.
Okay, but definitely the animal locomotion part.
Exactly. So somewhere out there, there's a scientist with a stopwatch, a snail, and a very patient researcher that is just working to answer a lot of important questions, but basically studying gastropods and how fast they go. So this is the world of professional snail racing. And there's two sides to this here, okay? So now before we dive into what has to be the slowest sporting event on Earth, let's talk about the athletes themselves, the common garden snail, or other known as Cornu asperium, formerly Helix aspersa.
Wow, those are really good pronunciations.
I just went for it. It could both horribly be wrong.
It sounds right.
So the common garden snail, I keep saying ground snail. Like, where else is this snail going to be?
Aerial snail?
Anyway, yeah, right. That would be so cool.
Yeah.
Like, imagine that snail coming from the air.
Just
like, to him, it'd be like,
ramping.
ah! Like,
Yeah.
right? So fast. So the common garden snail, or brown-shelled snails, you find sliding along sidewalks after it rains. They're native originally to the Mediterranean, but have spread pretty much everywhere humans have, from California to English countryside, everywhere in between. So garden snails are hermaphrodites, meaning every individual is both male and female. They're nocturnal and spend most of their time eating, or more accurately called rasping, because of how their mouth and everything is. I don't think we've talked about snails before. Have we?
We did in a sex episode, because we're talking about the darts, the love darts.
Okay. That's right. And I know I talked about them in the armor one because of the volcanic snails at the bottom. Okay. So when I say it's rasping, they have a microscopic tongue called a radula, which is covered in thousands of tiny teeth, basically to scrape up algae, plant matter. I love picturing
it. It's like a cat tongue, just like...
Yeah, like a very abrasive cat tongue. Yep. So every summer, though, all right, in Congham, England, people gather for the World Snail Racing Championships, where dozens of snails line up at the center of a damp, wet circle, and the first to slime its way out to the edge wins. So on their official website, because of course there's an official website, there's a slogan that says ready, steady, slow. But several other websites I said quoted as that their slogan or their motto is not fast, just furious, which is so much better than ready, steady, slow. So I don't know who they need to talk to adopt the not fast, just furious slogan. But anyway, so in England, they have these World Snail Racing Championships. And while it does sound like a small, town fair game gone rogue kind of thing, snail racing actually overlaps with real scientific research, because of how snails actually move is shockingly complex for it being a snail.
Yeah.
So snail scientists called malacologists, I guess, and biomechanic researchers study snail movement to understand the chemistry of their slime and the physics of their crawl.
That makes sense. That it's like the same as my last people, the biolocomotion, the fluid dynamics, how is this substance?
Yes. So turns out that snail slime is a non-Newtonian fluid, which is a fancy way of saying it doesn't behave like water or oil, because it's both sticky and slippery at the same time. It's thick enough to hold a snail upside down on a wall, but slick enough to let it glide across like razor blades without harming them at all. So that bizarre dual personality of slime that they have has researchers like Dr. Brian Chan, an engineer at MIT, who studied how the mechanical waves that snails send through their feet interact with the slime underneath.
Cool.
So basically, the snail's entire foot moves in a slow, coordinated ripples, like a treadmill made of muscles kind of thing, if you think about it that way. Yeah. And those ripples push against the slime just enough to break microscopic bonds, allowing the snail to slide forward while still clinging to the surface. So it's biological equivalent of like walking with glue sticks on the bottom of your feet. You know what I mean? So because of the slime chemistry changes depending on humidity, temperature, and even surface toughness, some scientists, like another one, Dr. Grameen Ruxton from the University of St. Andrews, has been testing how different snail species perform under specific conditions, which again is like explaining that over a dinner party. I study snails.
Well, today the humidity was high and my snails were having a really hard time gripping on.
Right? Yeah. So here's the thing with both of these scientists, and again, they've done a lot of research, and so you can kind of dive into that a little bit more. Studying snail movements isn't just about, not a useless thing. It has real world implications. And again, they go to these, I don't know if I didn't find any but these two, but there are other snail researchers that go to the world champions and all this stuff. So anyway, because the snail slime is kind of like a biological super glue, it's strong enough to hold a snail upside down on glass, but gentle enough to peel off without damage.
Yeah.
So engineers have been trying to recreate that exact balance. And honestly, right now, they're getting pretty darn close.
Cool.
So medical researchers have been developing, including these two, their research is funneled up in developing snail-inspired adhesives for things like wound closures and other surgical glues. So these new materials could stick firmly in wet environments, like inside the human body, but still dissolve safely when they're no longer needed.
Fascinating.
And that's something like traditional stitches and tape still can't do, because yes, it dissolves, but like that's a chemical.
Yeah,
you know what I mean? Like that's a chemical. There's something yeah. Whereas this is more of a all natural. Like how else do you explain it? You know what I mean? It's not it's
it kind of reminds
natural
me
way of doing things.
It's like oobleck or like non-Newtonian. It's hard in some contexts. It's smooth and liquidy in other.
Yes,
it's got so many different properties that you could then use for other things.
Yes,
and like the lubrication, I would assume too, like lubrication in machines. Like surely that has to be an application for the slime. Yep.
Oh, tons of things. So then the first scientist I talked about, that he was watching like the foot movement and everything. So a lot of his research is going towards like robotics teams are borrowing from snail physics to build quote unquote soft robots that can squeeze through tight places like collapsed buildings, underground pipes, and even inside blood vessels, which is crazy. So because then inside the blood vessels, especially, they crawl, quote unquote, instead of roll through it, if that makes sense.
Yeah, they're just rippling through.
And so And so I guess it's a lot safer and a lot easier, I guess, than the rolling motion, because it doesn't quite get like tangled. And so there's like all kinds of positive things that can come from that, from mimicking a snail rather than something that's rolling. And so the secret of all this is mimicking how snails control friction with micro adjustments in their mucus. So it's almost like the combination of the two.
Yeah.
So beyond even tech, researchers have been helping ecologists understand how snails survive in changing climates. And by studying how their slime chemistry shifts with humidity and temperatures, they can predict how snail populations and the ecosystems that depend upon them might adapt as the planet warms and all. So it's not just like they're just doing this simply because of the positive human implications. Yeah. They're also helping other biological scientists understand snails and the ecological impact. Because again, snails are beneficial to the world around us. So yeah, it might be funny in it because it is to be like, yeah, it's snail races, but that's literally what they're doing because they're studying so many different parts and ways that a snail is moving between the locomotion part of it, but then also the slime because of the benefits of both of them.
That's so cool.
So yeah, that's snail racing.
That's amazing.
So, all right, guys. Well, that is, what is that? 4 weeks of mini episodes. So we're going to have another normal long episode next week and then a short episode after that. So make sure between now and then you follow us on Patreon and support us if you can. And then go follow us on our social media pages, Wildly Curious Podcast. Until then, we'll talk to you guys next week.
Bye.
To space long ago, dinosaurs trained for delivery runs. We're asking the questions, the weird ones. Wildly curious, where science gets strange and kinda hilarious. From nature's wonders to ancient funk, it's facts and fun rolled into one big chunk. Wildly curious, weird is wonderful. Come join